Network fundamentals and TCP/IP. So if you take this program, we have this program divided into three parts. Now, one, the fundamentals. Two, routing. Three, switching. So these are the three main sections of this program. The fundamentals, followed by routing, followed by switching. In network fundamentals, we'll be learning about what all makes the network happen, the components, the protocols. We call it as network fundamental. And also, in network fundamental, we learn additional features like securing the network, like access control list, network address translation, NAT, subnetting, and much more. All right. So this network fundamental uh, takes around 40% of this training, and then let's say routing will take like another 40%, and switching will take 20%. Yeah. So that's how this training is going to be. This is the most important training than any other high level trainings. When this training is good, the other trainings, the next level trainings will be easier. This is the very important fundamental training. When we don't have proper understanding in this training, it's no use of going to the next level. This is the fundamental level which provides all the important information to understand networking. In Cisco, network is taught in three different levels. CCNA, Cisco Certified Network Associate, which we are in. This is the first one. After which we have CCNP, Cisco Certified Network Professional, followed by CCIE, Cisco Certified Internet Expert. We got these three levels. Right now we are in this level. This is the most important level. And when we don't understand this proper, when we don't learn this proper, this too is going to be very difficult. And this is the important one, which teaches the alphabets of a language. Alphabets of a language are more important than um, than speaking some word. If you don't know how to read, if we don't know how to pronounce, you know this, right? For a child, that the kindergarten, the primary school, those are very important. If they don't do well in that, then higher studies will be difficult for them if they don't do the basic studies proper. Likewise, what you're going to learn in this program is the most important in networking. Now, when we talk about the history of IP, right, it was long back, like 1970s, it was introduced. And later, it has become a standard in 80s. IP stands for Internet Protocol. And now you have seen people talking about IP address. It will look like this: 10.15.100.1. This, we call it as IP address. The reason is this is the format of number that is used by the IP protocol to identify a device. This is the format. This is the way that the address is written, so that the protocol IP can use it as an address. Without IP, there is no networking. It's completely IP network we are in. Even right now, as I'm talking to you, I'm using the IP, the Internet Protocol. You cannot exclude IP. Base is IP. All other protocol will come under IP. IP, TCP, UDP, and a TCP telnet, SSH, HTTP, DHCP, DNS, and so on. All protocol, they come under IP, Internet Protocol. So we'll learn about IP much more in this training, and then today we'll start about this one. We'll start to learn about OSI layer, Open System Interconnect, Open System Interconnect. Open System Interconnect. This one explains how a packet is prepared for communication. Right now I'm talking to you. My packets are prepared so that the packet will deliver only to you, those voice that I'm talking, the video that I'm sharing, those are all prepared very well and delivered to you only, because you are the only one who has joined this class. It's not broadcasted to the entire world. It just comes right to your computer, your laptop where you are in, which means there is some sort of preparation, and see, it is delivered to your IP address, your MAC address, and when it comes to your device opens it with the right application, this Google Hangout. The voice that I'm sending, the video that I'm sharing, it is not coming in a Word format for you, nor any other format. It comes straight like the conference packet, the packet that is needed for the conference, the video conference that we are doing for the class. So there is something in your laptop and my laptop, between in my computer and your computer, to understand and use it. For example, if I'm sending something, breakable, a glass in courier, I write it on the top. It's glass inside, handle with care. So those who handle the packet, they understand that it needs to be given some extra care. So they provide some extra care to that box. Likewise, from my laptop, when I send a packet, and if it is a voice packet, everyone who handles that packet in the middle, they know it's a voice packet. And the receiving device, which is your computer also knows that it's a voice packet. That is why it is collecting all the data which I am sending, the voice data, and you are able to hear in your headset, in your earpiece. It is not going to some other application in your laptop. It goes straight to your sound application so that you can hear me very well. So in short, what I want to say is, for communication, the packet needs to be prepared well so that the sender and the receiver will have the same meaning to the data. The same meaning in which the sender has sent, the receiver will also receive. Now, open system interconnect model. What is the word model here? Why we are calling it as model? This is a document which explains how the packet needs to be generated, how the packet needs to be prepared. It explains. It is a model, it's a reference book. OSI, Open System Interconnect, is a reference book. Everyone needs to refer to this book in order to design a computer. See, I'm in different part of the world. We are not in same region, and we did not purchase a laptop from the same shop, but still we are able to communicate through this laptop. How is that possible? Because the entire world has followed one model when they designed their laptop, when they designed the computer. There's one common book which is referred. According to that book, according to that model, my laptop and your laptop is created, is designed. So when I generate a traffic from my laptop, your laptop collects the traffic and understands the same meaning in which I have sent. This laptop and your laptop understands, my laptop and your laptop understands each other because they have the same architecture, same model, same language they speak, you can say. That's why it is called model. Needs to be referred as a model. OSI, open system. See, only then the system will become open for interconnection. Open system interconnect. If you want a system to interconnect each other openly without any barriers, this model need to be referred. Now, this model consists of 7 parts, called as 7 layers. OSI is 7 layer. Number 1, the physical layer. The physical layer. This need to be learned in sequence, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. You can say layer 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7. So always layer 3 is network layer. Always layer 6 is presentation layer. We should not shuffle it. No, should not shuffle it. It needs to be learned in order. So OSI reference model consists of 7 layers, physical layer to application layer. Now we are going to see one layer after the other. But again, I'm telling you, you need to remember this in sequence. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Yep. So order is important. Fine. Now let's see one by one. All right. So this is what I said. Layer 1, physical layer. Layer 2, data link layer. Layer 3, 4, 5, 6, 7, Because this is in the top, we should not call this as layer 1. No. Application layer is always layer 7. Physical layer is layer 1. Why? Why should I follow this number? Because it's a standard. The standard things should not be changed. It should be strictly followed the same way it is given. Physical layer is the first layer. Now, as I said, physical layer is the very first layer in OSI model. Layer 1. Now, what is the responsibility of this layer? The responsibility of this layer is to provide connectivity. You see, my laptop has recognized that there is a Wi-Fi. And through Wi-Fi, my laptop understands that it can send and receive data. And it has made it available for me to communicate. So physical layer is the layer which is responsible for physical connectivity. When I say physical connectivity, it need not to be a cable. It can be a Wi-Fi. There's a Wi-Fi router in our house, and there is a Wi-Fi transceiver in your laptop. So this transceiver in your laptop can see that there is a signal in the air, and the signal is sent from a Wi-Fi router. So the laptop can now connect to that router so that we can send the packet out of this laptop and receive the packet from the internet into the laptop. When you speak, my laptop receives the data from the router into the laptop. When I speak, the data goes out in the form of radio signals to the Wi-Fi router. From there, it enters into the wire. Through the wires, it has reached you. Big thing. Many thousand kilometers away you are, but you are able to hear simultaneously at the same time as I speak. But there are many technologies in between to make this communication happen. But all these technologies in the middle between my laptop and your laptop has got physical layer, meaning the layer which is responsible for taking the data in and sending the data out. Now, how is this data going in between my laptop and your laptop? They're not going in the form of human voice. They go in the form of electric current. The data is sent in the form of electric current. Electric current has got a language called on and off. On, off. With this, they found a language called binary. Binary 1 and 0. 1 means on, 0 means off. And with this binary number, big numbers can be formed. For example, if I want to write 7, in binary they write 4 plus 2 plus 3, which is 7. Meaning in binary language, if it is 1 here, 1. If it is 1 here, it means 2. If you have 1 in the third place, it means 4. You add and see 4 plus 2 plus 1, 7. So you got 7 by adding this. And you got 4 to 1 because it's binary. And binary has got only two numbers, 0 and 1. 0 and 1 is because the electric bulb, if you take, you can off it, you can on it. That's the two language the electric signal knows. So our data are sent electrically, means this. It is sent in the form of binary number, 0, 1, 1, 0, 0, 1, likewise. So if you sniff any packet in the middle between my laptop and your laptop, if someone takes the packet and if they try to read it, it will be all in the form of 0, 1, 1, 1, 0, 1, 1, 1, likewise. Because the data are sent through wire as an electric current. 0 means off, 1 means on. It's same like, the telegraph. In olden days, we used to send a telegraph. Same like this. Anyway, in OSI, the layer 1 means physical layer, which is responsible for physical connectivity. Without physical layer, our computer will not know from where the internet is coming. Our computer will not know to whom the packet needs to be sent if someone wants to use the internet. So the physical layer understands that there is an internet signal coming in the wire. For example, if I connect a wire to my laptop, immediately my laptop will recognize that there is an internet coming, that there is some signal coming, and it will connect to the signal for communication. Fine. We have a device which works in this layer, physical layer. We have a device, and the device is called hub. Hub. Now, I would like to talk about devices for some time, and then we will go to the second layer called uh, data link layer. This is the second layer, but let us not get into that now. We need to talk something about the devices. In networking, we have various devices. One of the devices, hub. It looks like this. Hub. Before hub, there was a device called amplifier. After amplifier, repeater. After repeater, hub. So we are trying to learn about this hub, but you need to know the history from where it started. Amplifier. You see, for a long distance, they use this amplifier. For example, if this computer A and this computer B, if it is very close, they can easily communicate, no problem. But what if this one is not too close? Not close enough for communication. If A and B are too far, there is a need for a device which will increase the signal strength, because more longer the wire, the signal gets weaker and weaker. For example, here the strength of the signal was this much. As it travels, it diminishes, and it will vanish. But when you have an amplifier here, it will again boost the signal up. It boosts the signal so that B can hear the data. Now A sent the data and B received. It is because there is a booster, there is an amplifier in the middle. But the problem with the amplifier is it amplifies all that comes in. For example, on the path, if there is some noise, if a noise gets added on the path, see, there are possibility of adding some noise. Noise gets added as the data travel because of earth magnetic attraction, because of some electrical line on the roadside, because of some oven, the cooking oven. They all generate some radiation. So those will disturb the data that is going through the wire, and those are called as noise. Those unwanted data that is added in the path, they're all called noise. So even the noise gets boosted, and the receiver, he receives data as well as some unwanted symbols, unwanted noise. Unwanted data is what we call it as noise, which was not sent by us, which got added in the path. They are noise. Amplifier even amplifies the noise. Yep. So they came up with another device called repeater. When we have repeater is nothing but regenerator, regenerate. When you introduce repeater, the regenerator, it regenerates only the data. So when a noise enters, it will be filtered. Noise is filtered. Noise get filtered if you have a repeater. See, the noise is coming, and in the output you don't see any noise. Meaning repeater can identify the difference between the actual data and the noise, and it can filter the noise. See, so far I have delivered these things. What we have a layer called OSI. The data are prepared according to what this layer says, so that communication will be possible. In that, we started with physical layer. Physical layer is responsible for physical connectivity, Wi-Fi adapter, Ethernet port to which you connect your wire. They're all physical layers. We saw in the physical layer the data goes in the form of electric current. Electric current. The data goes in the form of zeros and ones. Yeah. And there are various devices in the network which helps us to communicate. One of the devices is called hub. Hub works in layer 1. Hub works in physical layer. And now we are trying to understand this device called hub. To understand hub, we need to understand the background from where it has started. For long distance communication, we need a device that will boost the signal because the data cannot travel for long distance. See, many thousand kilometers away, we are able to talk as if we are sitting in the same place opposite. How is this possible? It is because there are a lot of devices in the path which has regenerated the signal, the voice. One of the devices amplifier. Today you don't have amplifier in the market because amplifier, they amplify even the noise. So to filter the noise and amplify only the data, they came up with another device called repeater. Repeater regenerates only the data. It can filter out the noise. That's repeater. But even the repeater is not in use today. Why? A repeater can only connect two devices. Repeater has got only two ports. Just two ports. So if this two device needs to communicate, you connect this device to this port, this device to this port. Finished. What if I want the third computer to communicate? If A, B, C, if they want to form a group, not possible because there is no port available. That is why hub was introduced. Hub is a multi-port repeater. Hub is a multi-port repeater. Hub is a multi-port repeater. Sorry. Right? Hub is a multi-port repeater. You can now connect, if this is a hub, then you will not have just two ports, you will have more ports. You will have more ports. Now you can connect this third device here. That is what you are seeing right now in this blue picture, blue big diagram. Hub. Hub is a multi-port repeater. See the background. It started from amplifier to amplify the data because the data cannot travel for long distance. But the drawback of amplifier is it is amplifying everything that enters in. If a noise is entering in along with the data, it amplifies both. But the receiver wants only the data. Amplifier amplifies even the noise along with the data. So when the receiver receives the data, the receiver can find some unwanted characters, unwanted letters. So to avoid that, to filter the noise, a repeater was introduced. A repeater was in use before this hub. The drawback of repeater is it has got only two ports. Repeater has got only two ports, so you cannot connect the third device. Only two devices can communicate. So multi-port repeater was introduced, which is called hub. So hub is also same like repeater, which can filter the noise. At the same time, it can support more number of devices. You see, device A, B, C, D, all can communicate through this one box. These four computers have formed one group because you got one hub in the middle. How many ports a hub can have? A hub can have up to 8 ports. A hub Maximum number of port is 8, which means you can only form a group of 8. You can only form PCs group of 8. That is again a drawback. Today we have at least 15 people in a department, in an organization. So this 8 is not sufficient. Hub has got only 8 port as the maximum number of port. Why is this limitation? Because in hub you don't have much controller. You just got only one controller. What controller? You have, in order to control the broadcast, in order to control the collusion, to control the collusion and the broadcast, you have only one controller. If you have only one controller, you cannot handle more traffic. That's why the port is limited to 8. The number of ports in hub is limited to 8 because you got only one collusion domain and broadcast domain. You just got only one collision domain and one broadcast domain. That's what I mean one controller. Controller means domain. Domain means controller. In order to avoid the collusion that may cause when all are communicating through this box, there are chances of collusion. Collusion, you remember collusion? Congested, getting lost. But to avoid that collusion, there is only one controller for the entire box. Likewise, if someone is sending a traffic, it is sent as broadcast to every other computer. If all sends data, then there will be too much of broadcast, which may cause collusion, a traffic jam. To avoid the traffic jam, to avoid the collusion, to avoid the collision caused by broadcast, you got only one broadcast domain, only one controller. Because you just got only one controller to avoid collision and broadcast, this device cannot have more ports. More ports, more device you will connect, then more collision it will be, more broadcast it will be, and it will become very difficult for communication. That is why they have limited to 8. If you have 8 devices connected to this one box, this one controller can somehow manage it. But when you have more than 8 devices, then one controller cannot manage. Then no one will be able to communicate if someone is not managing. Why do we have a supervisor or why do we have them? So that they can control the class, they can control the crowd, so that everyone will be happy to be there. For example, if you are in an exam hall, there is a proctor, there is a supervisor who supervises the exam, so that no one will copy and no one will easily pass without studying. Only those people who have studied well will get the reward. So it's good to have a supervisor. If there is only one supervisor for 100 student, then there are chances some may copy, and that's not good. So we have a controller to control the flow of data, to control the collusion, to control the broadcast. And we got just only one. With just only one controller, you cannot have more number of ports. If you don't have more number of ports, then you cannot have more number of devices in the group. So that's the drawback of this device called hub. Hub has got only one controller. So the number of ports the hub has got is limited to 8. So only 8 devices at a time can be in a group. Again, I want to remind you, hub is also not in use because it has got only one collusion and only one broadcast domain, only one controller. And again, the number of ports are limited to 8. That's the maximum. Some hub have got only 4 ports, some hub have got 6 ports, some have 8 ports, not more than that. Today, networking has grown very big. So with that 8 port, you cannot have more devices. That is why we have another device called a switch in layer 2. Switch is an intelligent device. You can even see switches of 300 ports, right? So we will talk about this layer 2 in our next class. We'll begin from here. Today is just an introduction to networking. In that, we saw how IP is important. IP is the base protocol. Only on top of IP, all other protocols like TCP, UDP, Telnet, DHCP, all this comes into picture. The Internet Protocol uses an address. We call that address as IP address. It has got some specific format. We'll talk about that later. Now, before that, we should know about the reference model, OSI. What does OSI? OSI stands for Open System Interconnect. Open System Interconnect. Now, this OSI has got 7 layers. Physical layer down to application layer. This need to be learned in order, sequence. You cannot shuffle it. So, before next class, I want you to know these in sequence: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer.
All right, gotcha.
And then we spoke about physical layer. Physical layer is layer 1, which is responsible for physical connectivity. And inside this layer, data are seen in electrical current form. I explained to you what the electrical current can speak. It speaks only 2 words, off and on, 0 and 1. We call this as binary number. Using binary, only the data are shared over the wire, the electric current. So when we speak about device, there is a device called hub which operates in this layer. Before hub was amplifier and repeater. Even hub is also having some limitation, like there is no more than 8 ports because of single collision and broadcast domain. We'll talk about this collision and broadcast domain again and again in various other topics so that you will understand that better. As of now, to control the broadcast, you have a controller called broadcast domain. Likewise, to control the collision, you have a controller called collision domain. So there is only one. If you have more, then more traffic it can handle. Because you have only one, the maximum number of devices that can be connected is only 8. That is again a drawback. That's why we have another device called switch. But switch operates in layer 2. Switch operates in layer 2. We'll talk about this switch in much detail when we start learning about switches. Layer 2 called data link layer. Data link layer, where the very important address called MAC address resides. Every device have got a unique address called MAC address, which is 48-bit size. MAC address is 48 bits in size. Yep. This is what we are going to start with tomorrow in next class. Next class is on Monday.